Whoa, what's this? Oh, whoa, is this a tutorial series? I'm gonna be teaching you, yes, you, person watching the video. I'm gonna teach you how to make a Dandylike, and not just any Dandylike, a Dandylike that isn't on Roblox, on Godot, that you could probably put on Steam if you get far enough. You probably won't, if I'm being honest. First off, I should actually explain what a Dandylike actually is, or a Delverlike alternatively. They're both pretty interchangeable. You could skip this part of the video. I have timestamps. A Dandylike is a type of roguelike. You use an elevator to go through different floors, and on each floor you have to complete a specific task and also avoid enemies that kill you. The main thing is that you can't fight back against the enemies. They're kind of like Lethal Company, if you think about it. Kind of like vaguely like Lethal Company. So I mentioned Delverlikes and Dandylikes. Dandylikes are like a subset of Delverlikes. Delverlikes basically follow the same format, but have an item system where you get to start with different starting items that like have different active abilities. Whereas Dandylikes usually have a class system instead, where like you choose a class and it has a set amount of abilities and stuff, as well as stats. The main reason for this tutorial series, statistically, out of all the people that are making a game from this tutorial series, at least one has to be good. At least one person has to have a brain cell and no good game design. That's about it for the explaining part of the video. Let's actually get into the doing part of the video. We're going to be doing forward plus, and we are going to be naming this Dandylike tutorial. You can name it whatever you want. It doesn't matter. All right, let's create it. Okay, so we're going to start with a 3D scene. This stuff up here doesn't matter just yet, but you do want to like do Control S to save this. And we're going to name it main.tscn. And that will be where we keep all of our actual like gameplay stuff, basically. Yeah, you right click here, you click add child node. Then we want to do a character body 3D. This is going to be our player. Now, let's also create a collision box so that the player has something to stand on when they can actually like fall and stuff. So we are going to want to create a static body 3D, which is essentially just a static platform. And then we are going to want to add a child node to that, a collision shape 3D. This is the actual collision box of the static body 3D. And then on the right here, you'll see a thing called shape. This is a variable. You add a box shape 3D. Now we have our little collider here. This is the platform the player will stand on, but it's a bit small, so let's just like expand it out a bit. There we go. Our player also needs a collision shape. And on that collision shape, we are going to give them a capsule shape 3D for the shape. That way they'll be able to go up slopes and stuff, because I don't actually know if that affects being able to go up slopes, but usually the capsule shape just provides more leniency than any other shape. So we're also going to move them up. Do not move the collision shape inside them, by the way, because that will actually offset like the player's position. Like if I move this up here, the player is still down here, and that they're basically just going to be pushed into the ground ish. So yeah, make sure that is centered on the player. So now we have all of our basics set up. Let's also add a mesh instance underneath the static body, so that there we go, so that we can actually like see the floor. By the way, there is technically a way to like do like the visuals and collision at the same time using CSG boxes, but use those at your own risk, because those are genuinely so unoptimized. I have a laptop over there, and I made a my friend Sleepy, he made a map for our game out of entirely CSG nodes, and I literally could not step foot in the map without at least dipping to 5 FPS. And he also made the elevator out of CSG. So, like, I couldn't look at the elevator. If I looked at the elevator, it would drop, like, half the frame rate. Only use CSG boxes if you're, like, willing to, like, delete them later. In fact, I'll just use them now. They're good for, like, they're always good for placeholders. And then you want to turn on use collision for them. Yeah. It's just easier at the risk of, like, it's way easier to set up CSG, but also at the cost of, like, being poorly optimized as all hell. So now let's actually code the player. You're going to want to right click the character body 3D and click attach script. Now we're going to name this script player.gd. I'm going to create it, and here is our, and if you did everything correctly, here is the there should be a template script. This is our default. This is just basically just default for Godot. If we run the project and we want to click select current, and we can't see anything because I forgot to add a camera. We're going to add a camera, and that'll not let us see our player because okay, yeah. Go to debug, turn on invisible collision shapes. That'll allow you to see the collision shapes. Now you can see your player, and if you use arrow keys, you can move them around. That's very rudimentary movement. But we want more than this, obviously. Let's clean up the code a bit more. First off, we are going to want to remove these two. Jump velocity, we don't want that because these games don't have jumping. You can keep it if you want jumping, but, like, yeah. So we'll remove this code here. This handles the jump. And here, we have this constant speed. We don't want speed to be a constant because what if you want to change the speed for, like, a speed boost or something? So instead, we're going to do var current speed equals 5. Then that will be our current speed. Let's also make this a float by doing that. If you know what a float is, that good. But, like, if you don't, floats are basically just decimal numbers with decimals. Then there's also ints. There's int, which is just, like, a number with no decimal. That's basically all you got to know. Then okay, let's walk through ignore these errors for now. We're going to fix those in a second. So the first part of the script, it just adds gravity to the player. If it's not on the floor, we add to the velocity of the player, the gravity times the delta. Delta is very, very important. You're always going to want to use that. Delta is basically the time in milliseconds since the last frame. If you don't use delta, any amount of lag will basically mess up your game. Now, next, we are going to get the input direction. We use input.getVector, which allows us to get a vector2, which basically is just a variable with an x and a y value. It just grabs the left, right, up, and down arrow keys, which we will change later. We'll add WASD in a second. Now, direction. Direction is the actual direction you want the player to move in. So here we multiply transform.basis, which is very advanced, like, matrix math, and I do not want to get into that. But essentially, that's, like, kind of just the direction your player is facing. And we multiply it by this vector, and then we get it normalized. So a normalized vector, let's say we have a vector 2 with the values 1 and 1. Essentially, this is going to move that way. But a vector that's 1, 0 is going to move that way. The length of 1, 0 is actually shorter than 1, 1. Because if you move 1 on the x-axis and 1 on the y-axis, you're moving further than if you were just moving 1 on the x-axis and 0 on the y-axis. So essentially, by normalizing it, we make this one the same length as this one. That's basically what normalization is. I'm not getting fully in depth on what it actually is, because it is some insane math stuff if you get really deep into it. So if direction, that basically just checks if the direction is not just nothing, if you're actually moving. So then if direction, then velocity.x equals direction.x times speed. We're going to change that to current speed. And velocity.y equals direction.z times speed. We're going to change that to current speed. There we go. That's half of our errors fixed. Now now if direction is 0 basically, so if we're not moving, then it sets then we set velocity.x equals move toward, velocity.x 0 speed. What is move toward? So move toward, let's assume we have a value of 0 here. Now we want to move 0 towards 5. So move toward takes 3 values. First of all, it takes the starting value, which in this case is 0. Then it takes the ending value, which in this case we want to move to 5. And then it takes a step value, which is the amount you want to move it by. So let's say we want to move it over the course of 2 ticks. So we do 2.5. So that will essentially give us 2.5 since it adds 0. So it takes 0, it adds 2.5, and then it checks if it's smaller than the second number. So that'll basically just move any number you want towards the next, any other number you want. It's pretty easy to understand, I hope. I hope I'm explaining this stuff well. We want to change those to current speed too. And boom, that's all the errors fixed. Last of all, we call move and slide. Move and slide essentially just tells the game to move your character based on the velocity that you've set. Basically, always call it when you're done with all of your calculations for movement. So now, if we test the game, it's about the same. It's literally exactly the same as before. But now the code looks nicer. Now, we are going to add our custom keybinds. So we're going to go project settings, go to input map, and we're going to want to add an action. Let's start with left. We add left, then we click this plus button, then you press the key you want it to be. So let's do A, and cool, we have left. Now let's do that for right. We want that to be D. Oh, yeah, D. We want forward. We will make that W. And we want backward, which we want to be S. There's a WASD. Now in here, we'll just replace them with what we want. Left, right, forward, and backward. Now, if we run the game, you can use WSD. Nice. But as you can see, it looks very dark. It's very, very dark. So we're just going to add the sun environment from this so that it looks exactly like this. So if you press these 3 bars right here, it pops up this menu. Then just click add sun to scene, click it again, and add environment to scene. Then when you run the game again, it'll look like it does. Yeah. So now we want to actually make it so that the player is in a scene. Because if the player is just like this, if they're just attached to the scene, the main scene, and that just means like if you want to spawn in players individually, you're going to have to create multiple players. And we're going to want to spawn in multiple players because this is going to be a multiplayer game. So let's turn them into a scene. Right click them and click save branches scene. Name it player and boom. There is our player scene. And then when you it's down here, you can see the players there. Double click that. And there's our player. Now they're an object that we can instantiate. And we can create multiple of them to actually make multiplayer later. The multiplayer is going to come a bit later. I'm going to show you how to add a lot more of the basic mechanics first. So, first of all, we're going to add a node 3D. Then we're going to drag and drop our camera 3D into there. It may seem a little confusing on why we're doing that. But basically, the reason we're doing that is so that we can do this. Yeah. That basically acts as like a pivot point for a camera. So then we'll just be able to rotate around that so that it's third person. So now we're gonna want to make want to go into the player script, make a new function called func_input. Press enter. It should autocorrect to say that. So input event is basically it runs whenever an input is given to the game. We're going to basically just check if event is mouse input event mouse motion. That will allow us to actually check if this specific event is moving the mouse. So then first off, we're going to want to get the sensitivity of our mouse. So first, let's define that. Var sensitivity equals 0.1. Feel free to adjust this based on your like preferences for mouse sensitivity. You'll be able to test it out later and come to a conclusion on what you like. Now we are going to want to actually rotate the camera. So let's start by getting both the pivot and the camera. So we're going to want to create an export variable. We're going to want to name it camera pivot and give it the type of node 3D. This will allow us to go here. Oh, we got an error. We got to type pass. There. That's just a placeholder. So now you see camera pivot on here. Click assign and assign it to our pivot. Okay. First off, we're going to rotate first things first. We are going to rotate our player. So rotate Y. This will allow us to rotate our actual character. So then we will want to rotate them by event.x. Negative event.x times sensitivity. Then, before that actually, we're going to want to rotate X. We're going to want to rotate our camera pivot. And rotate it by the event.y. So now, if we go into the game, ooh, I got something wrong. Oh, no. You're supposed to do event.relative.y. Boom. There we go. Oh, okay. That is very... I mean, it works, but it's very, very sensitive. Okay, I checked. We are going to want to do deg to rad. Basically, what that does is it converts degrees in rotation to radian rotation. That is also some insane math stuff. But basically, degrees are way bigger than radians, and Godot, by default, rotates things by radians. So we want to convert these from degrees to radians. Because most people are way more familiar with degrees than radians. Because radians are very, very weird. So now, if we go into the game, you can see we rotate pretty easily. But, our mouse isn't locked. So let's do that. We are going to want to create a ready event. This basically just runs when the player is initialized. So when they're created. So let's set the mouse to locked. Input dot mouse mode equals input dot mouse mode hidden. This will hide our mouse and allow us to it's not hidden. It's captured. Yeah, mouse mode captured. There we go. Our mouse is now captured, and we can freely move around. Nice. There's our basic movement. But also, you could do this. That's very disorienting. So let's not do that. The way we do this is by making it camera pivot dot, oh my god, I cannot spell, rotation dot X equals clamp. And then we're going to want to clamp it between deg to rad 90. Deg to rad 90. And we're going to want to make the minimum negative 90. So basically, that'll prevent us from looking looking above and below 90 degrees. But 90 degrees is a bit much. So let's just make it like 80 here and 80 here. Now, that's a bit more reasonable. But you can notice we can look through the ground. There's a way to fix that. Don't worry. Let's add a spring arm. That'll essentially make it retract the yeah, there we go. That'll essentially make it retract the camera when it touches the ground. And boom. So now, yeah, that's all of our basic mechanics. I mean, not basic mechanics. That's our basic, like, being able to move. So now, let's move on to our first thing that isn't like a basic Godot thing. Character loading. Character loading allows us to actually load in characters and, like, have them apply things to our main character, our main player. So, this is going to be a pretty easy thing. First off, let's create a new scene, make it 3D. We're going to want to name this base character. Base character is our base character. Pretty obvious. So now let's add a script to them, and let's rename it base character to keep our naming convention. So now we get to add some values to our character, like our stats basically. So let's do var speed. Oh yeah, we also want to make these all exports so that we can modify them. Var speed int export var stamina int. So for now, we'll just be using speed, stamina, and stealth. You'll see why later, since I'm going to add multiple different task systems to this. So we are only going to need these three, and these are the only three that we will need. Fuck, that sounds dumb. We're also going to want to go at the top. We're going to want to do class name base. We're going to do class name character. That makes it so that we can reference this elsewhere, so that we can actually get autocorrect on the speed, stamina, and stealth. That will be very useful later. So now, this character is actually where we're going to keep the model for the player at. Except I don't have a model on hand, so I'm just going to make them a fucking... I'm just going to make them a fucking bean. They're just a bean. Yeah. So here is our base character. They looked very ugly. If you have an actual model for a character you're adding to your game, this is probably where you're going to want to add it in. But yeah. So now, let's go into here. We're going to want to actually load in our character. So let's make a custom function for that. Func_load character. And we're also going to want to be able to pass in a value of the actual character. Character. We're going to want to do a packed scene. A packed scene is just one of these. It's just one of these scenes. So we're just going to send it that, basically. For now, let's just put pass there. And then in ready, let's call _load character. Then let's actually pass in that scene file. So load, and you should be able to see basecharacter.tscn. Yeah, the load function just loads it. That's about it. So now we have our character loaded. Let's actually like add them to the player. So over here, we want to create a new node. Let's name this character. So now we want to just take this character and just add it to that. So let's do var character. That is why we put that at the top there, so that we can make this variable a character variable, because that is very helpful. Equals character dot. Oh, I gave them the same name. Let's just do new character. Yeah. Then we do character dot instantiate to create a new instance of this scene. Then we go $ character, which allows us to reference this node, and then dot add child, then pass in new character. Now we have our character in our scene. You can't see him though unless you play the game. Boom, there's our character. So then let's just do a very basic scaling for the speed stat. So the way I do scaling is through curves. So let's start by actually adding a curve. We're going to want to do @export var speed scaling : curve. We do actually just want a regular curve. There we go. Okay, yeah. This curve actually actually works. So essentially, this curve is a 2D graph which lets us like plot out how we want our speed scaling to go. So we are going to set the max domain to 5 and a min domain to 1 because we want 1 to 5 stars as scaling. And then the min value and max value. Please, for the love of God, do not use the stats of speed from Danny's World, because those suck ass. They're terrible. Instead, we're just going to do like a basic. We're just going to use like a basic system. We're just going to go between 6 and 7. I did not mean to do that intentionally. I'm going to kill my... I did not mean to do that intentionally. That's just the scaling of my other... That's just the scaling in my other game. So now we have our little... curve. Let's make it so that these are actually straight too, by just making them both linear. Boom. There's our scaling. So now we actually want to like modify our speed based on that. So we'll do speed. So we do current speed equals speed scaling dot sample, and then we pass in new character dot speed, and boom, there is our speed scaling. We didn't actually set the values for this character though, so let's set this to 3 3 3. And when we go in here, you can't actually test that, so let's print it out. We're going to print we're going to want to print current speed, and we're also going to print new character dot speed. Then let's do a quick test. So now you could see our speed is 6.5 because we are at 3 star. But then if we go down to here, we move our character to 5 stars, then they'll be faster. Very slightly so. You can't really tell through me testing, but the speed is different. Yeah. Okay, so now we have all of our very, very basics. That is the end of this tutorial. The next tutorial, I plan on doing stamina, the elevator, and probably items. Yeah. Bye.